In this lesson, we're going to learn the impact the Datapath cycle have on the performance of the CPU. Fast forward, what is Datapath cycle? Datapath cycle is the fetch, decode, execute cycle that a processor hardware performs. The Datapath cycle is made up of several components, which is the memory, program counter, arithmetic logic unit, registers, and buses. The memory stores the current instruction, while the program counter stores the address of the current instruction. The arithmetic logic unit, ALU, it executes the current instruction, while the register stores the data, and the buses transfer the data between the elements. Most IT professionals call the Datapath as the heart of the CPU. Back to the Datapath cycle itself. This cycle plays a big role in how well the CPU performs its task. The speed of your processor also depends on the Datapath cycle. If the cycle time is short, then probably data will move very quickly through the CPU, and vice versa. If the data time is very long, meaning the data will move very slow, and that will surely reduce the performance of the CPU. You see, when the data time is long, the CPU has to take its time to execute the instruction one after the other. But when the time is very short, within a short period of time, the CPU will be able to perform its tasks. That makes the work of the CPU very easy and simple. We have what we call the single cycle Datapath. With the single cycle Datapath, each operation in the CPU happens in a single clock cycle. If the clock cycle is long, it takes more time to complete each task. Like I was saying, shorter cycle time can speed up the CPU by making the processor works very fast, but making it too short can also lead to error and complexity in the design. The diagram here shows what we call pipelining. Pipelining can be found in modern CPUs, where different stages of instruction are being processed or happens at the same time. In this stage, the Datapath cycle affects how well the stages work together. If the cycle is insufficient, some stages may have to wait for others to finish before they can continue. You see, because the pipelining is in stages, you can't skip one stage. You have to wait for the other stage to perform before you can move or proceed to another stage. And as a matter of fact, it has to slow the performance of the CPU because you can't skip. So you have to wait for others to finish before you can proceed. A good Datapath cycle keeps everything in sync for smooth and fast processing. And for the complexity, the more complex the Datapath, the longer it may take to complete the task. But it allows the CPU to perform a wider range of operation because the simpler task tends to run very faster. Another important thing about the Datapath is the width of the Datapath. A wider Datapath lets the CPU handle more data at once, making it very fast. For example, a 64-bit CPU can process more data than a 32-bit CPU in each cycle. As you can see the diagram here, you can check the speed that the 32-bit can process and that of the 64-bit. You see, the 64-bit can run very faster as compared to the 32-bit. And finally, memory access can cause delay. The memory access will cause delay when the stages in the pipelining has to wait for each other to finish before it can continue its task. Technologies like caching help reduce this delay, but the design of the data path still determines how efficiently memory is accessed. Thank you for watching. If you find this video educative, kindly share, subscribe, and comment.